So let me give you an example. So just a summary of the previous two videos. When given a function f of x here, if you know the gradient at this point here, then you automatically know the gradient of this point here. And then once you know the gradient at this point here, then you can work out the equation for the tangent line. Once you know the gradient at this point here, then you will know the gradient of the normal line, the perpendicular line that bisects the tangent line. Okay, so now I'm going to give you an example. I'm going to give you a function and then ask you to work out the equation of the tangent line and the equation of the normal line. Okay, so hang on. So given this function here, find the equations of the tangent line and the normal line of the inverse function here. So this red line here is your function here. Okay, and then find at x equals 6, so x equals 6 here of the inverse function. This blue line is your inverse function here. So find the equation of the tangent line, okay, and then find the equation of the normal line. So if you have yourself a graph plotter, plot this function here, and then somehow draw your tangent line, and then draw your normal line. And to do that, you need the equation of this line and the equation of this line here. Okay. Well, anyway, so to do this here, we've got the red line here is this function here. So if you want to know the gradient at this point here, don't forget, bear in mind that at the moment you've got a function here which is x to the power 3 minus 2. If you put the number 2 into here, it will spit out the number 6. So that means 2 here, 6 here. That means the point at 6 will, yeah. So this point here gets reflected to over here. So once you've realized that when you put 2 in here, you get 6 here. That pretty much gives you the location here. Well, anyway, if you can find out the gradient at this point here, then you automatically know the gradient of this point here. Okay. So to find out the gradient at this point here, differentiate this. So wait there. So originally we were given this function here. Differentiate it. That will give you this. Realize that when you put 2 into it, it will spit out the number 6, meaning that hang on. Yeah. Realize that when you put 2 into the machine, it will spit out a 6. What that means is you were asked to find out the equation of the tangent line and the normal line at this point here. So this is 6, 2. But realize that when you put 2 into the machine, it spits out the 6. So you need to find out the gradient at this point, because this point here represents this point here. Okay. So anyway, so start with your function here. Differentiate it will give you this, and then put 2, because you know that you put 2. Well, basically, in short, try to find out the gradient at this point here, which is what you're doing here. You differentiate it. That will give you this here, and then put 2 into here, and then so hang on, let me think. Yeah, so if you put 2 into here, the gradient is 12. Hang on, the gradient at 2 here. So this gradient here is 12. Okay, so it's you following this. So the gradient here is 12. Well, if the gradient at that point is 12, if the gradient here at 2, 6 is 12, then this gradient here must be 1 over 12, because once you will know the gradient at this point, then the gradient at this point will simply be the reciprocal of this gradient. Okay, so once you know this is 12, then the gradient here must be 1 over 12. So the equation for this line here will be, well, you know the gradient, you know it passes 6, 2, okay, because earlier it was 2, 6. So this point here will be 6, 2. So you know, yeah, so you can put 6 into the x, and then 2 here into the y. That will then give you this, and then blah 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 to work out c. C is 1.5. So the equation for the tangent line is given by this. Okay, and then for the normal line, you see, for the normal line, once you've got the gradient at this point, which is 1 over 12, then the gradient of the normal line will be the negative version of this, the negative reciprocal version of this, if that makes sense. So the gradient here will be 12 over 1, but the negative version. So the gradient of this normal line here is minus 12 over 1, which is just 12. So for the normal line, the equation, well, you know the gradient will be minus 12. And you know it crosses this point here. So you can put 2 into the x. Hang on, that's the y. So you can put 2 into the y here, and then 6 here into the x here, and then blah blah blah. C turns out to be 74. So the equation of the normal line is given by this. So the equation for the tangent line is given by this. Once you've got these two equations, this one and this one here, you can jump to your graph plotter and be able to plot this graph here. So your graph. Remember, this was our original function here, f of x here. The inverse function is this blue line here, okay. But then the tangent line, well, we wanted to know at this point. This point here is at 6, 2, okay. The tangent line, which is this. Well, I don't know if you can see it, but which is this line here. Which is this line here, which is this line here. Okay. Well, the tangent line here is the equation of the tangent line here is given by this, and this here, the green line. I don't know if you can see it, but it's this line here. It is at 90 degrees, 90 degrees, 90 degrees, 90 degrees here. The equation for this normal line is given by this. Okay. So yeah. So here, this is our tangent line. This is our normal line, and they are at 90 degrees, and so on. Okay.